Happy day everyone, hope you all are doing good and preparation is going really great. Here is another most important video from your chemistry point of view. Those who are starting just now chemistry or those who have completed some chemistry, whoever it is, from this video we are actually expecting 3 to 4 questions, okay? Because in this video I am going to cover the hybridization topic, the tricks to remember the shape, and also how to calculate the hybridization. If you learn this within 10 seconds, for sure you will be able to find out hybridization of any question if they ask, okay? Also we are going to deal with your bond angle, bond strength, bond length, okay? So just listen to this video. Even if you didn't read any of the chapter related to your block elements, that's fine. There is no need. Only watch this video and you will be able to answer the questions coming from this topic, okay? Trust me. If you're just now starting chemistry, it is better to know something than nothing, right? At least something you can able to answer from this topic. So yeah, listen to this video fully. It might be little long, maybe 20 or 25 minutes, but if you listen to this completely, you can able to answer any question coming from the topic, okay? Yeah, so before getting started, I have already posted biological tricks from the class 11. Many chapters I have posted. If you want to know that, please do visit the description in the link. Also Telegram channel is given in the link, for you will be getting the PDF there. Yeah, let's get started. So the first trick will to remember the shape of your hybridization. Those who didn't know what is your hybridization, how to calculate it, don't be worried, okay? Because just learn this trick first. Later we will be learning how to calculate. First, if you learn this trick, it will be easier now. So how we are going to learn? In hybridization, we have two things, okay? Bound pair and lone pair. As many of you know, if you don't know, we will discuss about it later. Yeah, bond pair and lone pair, okay? Whenever the lone pair is 0, that will come under a one trick, and if whenever we have lone pair, that will be coming under your another trick, okay? So yeah, the first set will be whenever lone pair is 0. So what you have to simply do, you have to write bond pair and lone pair, okay? Here you need to write from 2 to 7, okay? 1 will be not there for n bond pair. There always be start with 2, not with 1, okay? So in bond pair, you have to simply write 2, 0, 3 and 0, 4 and 0, 5 and 0, 6 and 0, 7 and 0. What it means? If bond pair is 3 and lone pair is 0, what is the shape? That's how we need to relate, okay? So now when bond pair is 2 and lone pair is 0, the shape is linear. When bond pair is 3, lone pair 0, trigonal planar. Bond pair 4 and lone pair 0, tetrahedral. Bond pair 5 and lone pair 0, tetragonal bipyramidal. Bond pair 6 and lone pair 0, octahedral. Bond pair 7 and lone pair 0 is pentagonal bipyramidal. How will I remember these tricks? I mean shapes, that is the trick here, okay? So there are two teams in a match, okay? Let's say IPL is going on, whatever you need to consider. There are two teams. In that, LTP team is in top, okay? There are two teams, right? Imagine this team is the LTP team and they are in top. So the trick is LTP team in top. That's it, okay? LTP team is in top. They are in top among the other team. So L is for your linear. TP, I said no, LTP. TP is for trigonal planar. Team is for tetrahedral. L linear is fine. T and P is coming. So trigonal planar. Team, TE, tetrahedral. So it is easy to connect, right? In is nothing, just for making the sentence. Again, T is for tetragonal bipyramidal. O is for octahedral. P is for pentagonal bipyramidal. Only T is repeating thrice. The tricks will be here itself. If TP means trigonal planar, TE means tetrahedral. So the remaining T you can memorize easily. Are we good with this trick? Whenever lone pair is 0, you simply need to write like this, and the trick will be LTP team in top. What if it is lone pair? What do we, if we have lone pair? It is very simple. Many of you here are the BTS fans, right? Yeah, the simple trick for this is BTS, okay? BTS, let's say. Here the bond pair, how will you write this? You have to write every number twice. Write the 2 twice, write the 3 twice, write the 4 twice, but 5 will be coming only 1, okay? Remember that. Here we are starting with 2 and ending with 7. This is in order. But while writing this trick, whenever a lone pair is there, you need to write everything twice except 5. Okay? Are we clear till that? Now, the lone pair will be repeating 1 and 2, 1 and 2, 1 and 2, 1. How to write this? Because this is important, okay? Only if you memorize this order, this trick will be useful. If you write here and there, you will be getting confused. So initially you have to write 2, 2, 3, 3, 4, 4. Everything twice except 5. Then you have to simply do 1, 2, 1, 2, 1, 2, 1. Okay? Now the trick I said, it is BTS simply. Okay? So B is for your bend. The both of your 2 will be coming to bend. That is, If your bond pair is 2 and lone pair is 1, the shape is bent. If your bond pair is 2 and lone pair is also 2, your shape is bent. That is given by your B. Now for T, these two, okay. Trigonal, pi pyramidal and T shape. So whenever your bond pair is 3 and lone pair is 1, the shape is trigonal pyramidal. When your bond pair is 3 and lone pair is 2, it is T shape, okay. The trick is given by BTS, no. So B will go for this 2, T will be covering 3. Now S will cover the remaining things. Are we good? B is for this 2, T is for this 2, S for the remaining, okay. When 4 bond pair, 1 lone pair is there, it is seesaw. When 4 bond pair and 2 lone pair there, it is square planar, okay. When there is 5 bond pair and 1 lone pair is there, it is square pyramidal. Any doubt? You might be asking, how will I remember laws 3 or starting with S only, right? And I have given only S. Remember the length. Seesaw, square planar, square pyramidal. It is in ascending order, right? This is smaller, this is little bit larger, this is larger than this. I mean the alphabets I am saying, the words number it is containing. So write it in that order, so it will be easy. So I hope till this we are clear how to remember the shape, okay. Yeah. Now we will want to just write it down anywhere. So at last it will be easier for you to revise once a glance, okay. Now we will move on to the next one, that is tricks for your bond angle, okay. This is containing 4 types. Listen to this properly, it is easy only. Yeah, the first type is whenever you are having 2, let's say CO2 and CH4, and they are asking which is having the more bond angle, or arrange according to the bond angle in the increasing or decreasing way. You need to find out the hybridization. Hybridization, how to find? If you don't know, again I am saying, please write, we are going to learn that also. Yeah, so to find the hybridization, you have to look at the hybridization and see your S character is directly proportional to your bond angle, okay. Because depending on your hybridization, whether it is SP, SP3, SP3D, whatever it is, okay. According to your hybridization, you need to see the S. What will be the percentage of S there, okay. Based on that, you can calculate the bond angle. Let's say in this example, CO2 and CH4. CO2 is having the hybridization as SP and CH4 is having the hybridization as SP3, okay. So here the percentage of S is 50%, half of them is S, but here the percentage of S is 25%. Like just by seeing itself you can calculate, no. Here only one S and one P is there, so imagine like that. So this will be in equal percentage, but here more number of P is there, so S will be less, right? This is how you need to think. Or if you want to know how many percentage of S in each one, I will put a separate video for that. So now are we clear? The first type of question is look at the hybridization. If the hybridization is different, yeah, see the S character. If the S character is high, that will be having the more bond angle. This is the first type, okay. Now we will see the second type. In the second type, if the hybridization is same, okay, you might be having a question. Now the hybridization is different. So here it is 50%, here it is 25%. I got the answer. What if the S character is same? What will I do? So the next type is if the hybridization is same and the lone pair are absent, okay. Let's say this is BF3 and BCl3, okay. In both of them, this lone pair will be absent and both of them are having sp2 hybridization, okay. Because let's say boron, in both of them it is BF3 and BCl3, right? How will you calculate the hybridization? F. This I will teach you in the next section slowly. This is Cl. So all the boron elements, the valence elements of the boron paired with in both F3 and Cl3, right? There is no lone pair. So in both the cases there is no lone pair and both belongs to sp2 hybridization, right? If this is the case, then your bond angle will be same. Nothing will be higher, nothing will be lesser, okay? So in the first case, your hybridization will be different and you will see the S percentage. According to that, calculate the bond angle. If your hybridization is same and LP, that is your lone pair, or absent, then bond angle will be same in both the cases, okay? See, everywhere you need to know how to calculate the hybridization. That is the important thing. Now, if your hybridization is same and lone pair or present, then what will you do? Then the answer will be your bond angle is inversely proportional to your lone pair. Okay, that means if your lone pair decreases, bond angle increases. Let's take these three examples. The first one is CH4 NH3 H2O. Okay, here CH4 will be having sp3 hybridization, NH3 is also sp3 and H2O is also sp3. As we discussed earlier, here hybridization will be same for everything. No, now see, in CH4 you will be having 0 lone pair, in NH3 1 lone pair, in H2O 2 lone pair. So now how to calculate this? See, your bond, if lone pair is decreases, bond pair will increase. So which one is having the least lone pair or 0? CH4. So this will be the greatest, having the greatest bond angle. The next one is for your NH3. Likewise, you have to calculate when the hybridization is same and lone pair is present. Okay. So this is of different type of hybridization. Hybridization is same, lone pair absent. Hybridization same, lone pair present. Now we are dealing with the fourth type, that is your hybridization is also same, lone pair is also same. In that case, we do have a two formulae. Initially remember this will be enough. Your bond angle is directly proportional to your size of side atom and size of your central atom, inversely proportional to the side of central atom. Like in case BF3, B is your central atom, right, and F is your side atom. So your bond angle is inversely proportional to the size of the central atom, directly proportional to the size of the central atom and inversely proportional to the size of the central atom. Okay, any confusion in this formula? SA and CA. Now let's see, discuss this. Okay, in this case H2O, H2S, H2Se, H2E. So in all the cases your side, that is side atom is same. So we can't calculate based on this. So we need to calculate based on your central atom, right? So let's see, O, S, Se and Te. So down the group, O, S, Se, these all belong to the oxygen family, right? Down the group your size will water, it will be increasing, your size will be increasing. So which is the one which is having the least size among O, S, Se and Te? Your O. So that will have the greater bond angle, right? Because these both are inversely proportional. Size of cation increases, central atom increases, your bond angle will decrease. So this will having the highest because O will be the least size. Am I clear? Any doubt? Then this, then this. Okay. In the same way, let's see for the next one. If you see the next one, it is PF3, PCl3, PRB3, I3. All belongs to your fluorine family. Here, all the central atom is P. So now we need to calculate with the side atom. So same here. Here your bond angle is directly proportional to size of central side atom, right? Let's see. Fluorine, chlorine, bromine, iodine. Down the group size will increase. So this is directly proportional. So size of side atom increases means bond angle will also increase, right? So in this 4, which will be having the most largest size? Your I3. So it will have the largest bond angle. So this way. Are we clear how to calculate? If we have a constant central atom, see the side atom. If we have the constant side atom like this, see the central atom. That's it. So now you are clear, no? Whatever type of bond angle, type of question from the bond angle it will be coming, you can solve it based on the hybridization. Okay, if it is same, if it is different, with lone pair or without lone pair, everything we have covered. Just note it down somewhere to revise on the last minute. Now we are coming for the important part of this video. Okay, give me a minute. So yeah, trick to calculate your hybridization. Listen to this carefully, then you can complete any of the hybridization question within 10 seconds. Okay, the first thing is valence electron. This is a simple trick. It is not even a trick. Let's see what it is. So the valence electron of group 1 will be 1. Okay, then group 2 will be 2. Then we are starting with group 13 to group 18. Okay, from group 1 to group 2, then group 13 to group 18. So group 1, group 2, if it is group 1, the valence electron is group 1. If it is group 2, the valence electron is 2. So what is valence electron? First of all, you all might be knowing though, the outermost shell. How many electrons are there in your outermost cell? That is called your valence electron, right? So now G3, 13, that is your group 13 will be having the valence electron of 3. Whatever there in the outer cell, it will come here. Okay. Now, in your group 14, what is there in last? 4. That means your valence electron here is 4. Simple, no? So, group 15, what it will be? 5. Group 16 is 6. Group 17 is 7. Group 18 is 8. So, whatever there in the last, that will be your valence electron. Okay? So, how to memorize what are the elements in the group 13, group 14? Separately, I have given tricks for each of the group. I will try to make a video for all the groups. Okay, what are the elements present in there, so it will be easier for you to memorize. Okay, so now are we clear? Because with this valence electron only we are going to calculate here. Okay, hope you are clear with the valence electron. Now there is a simple formula. Okay, hybridization equal to number of atoms attached to that atom. Okay, attached to that central atom, I can say. Okay, number of atoms attached to the central atom plus lone pair of that atom. Okay, how to calculate your hybridization? Simply the number of atoms attached to the central atom, okay, plus your lone pair of that atom. If you add these two, you will be getting this number from 2 to 8. With this, you can simply say what is the hybridization. This also you can simply memorize. Okay, if you know this, there is no need of thinking anything else. If it is 2, I mean here you are calculating, no. If the number comes as 2, then it is sp hybridization. If it is 3, sp2. If it is 4, sp3. If it is 5, sp3d. If it is 6, sp3d2. If it is 7, sp3d3. If it is 8, sp3d4. This is also like nothing to memorize, you know, right? Yes, then p will have maximum of 3, right? So, how many boxes we will write for p? 1, 2, 3 boxes that we are representing here, okay? Then d. In that order only it is there. Okay, now we will see the sums. Listen carefully, it is very easy. Let's say C is your central atom here. How many valence electron will C have? 4. So I am putting 4x. Okay, this is your, consider this is your valence. Here 4 are there. It is waiting for someone to love it. Okay, so it is waiting. These are now waiting as a single, so it is waiting for the love to come. Let's say how many are getting the love they want, okay, or how many are being single or lonely at the last. Okay, that is what we are going to see. So C is there, 4 is the valence electron, so put 4x. Okay, simply. Now let's say how many atoms are coming to it. H4, right? So for each one we have to connect to it. 1x will be connecting with 1x, another x with another with another h, another x with another h. I will we will do it here. Just listen to this, then we will do, so it will be clear. Okay, so now let's try to calculate this. What is the formula? Number of atoms attached to the central atom. This is the central atom. How many atoms are attached? 1, 2, 3, 4 attached, no? So this is 4. Number of atom is 4. Now your lone pair of atom. Are we having any lone pair? That is your single? No, all are getting paired, so it is 0. So 4 plus 4 equal to 4. If it is 4, what is your hybridization? sp3. That's it, guys. Okay, let's do for this one. No, let's do for xc, because H2O will act differently. Okay, so firstly we will complete for xc. Okay, so whenever, what is the valence electron of xc? You should see the central atom. Then what is the valence electron? It is 8. So put 8x. Okay, it will be easier. Once you are thorough with this, no, there is no need of writing also, because seeing itself you will be able to calculate. But as of now, if you have any confusion, put the number of valence electron. Okay, I have put 1, 2, 3, 4, 5, 6, 7, 8. Now I am filling how many pairs are coming. I am seeing how many pairs I am getting. Okay, there are 4f. So I am giving 1 for each. 1 for this, 1 for this, 1 for this, and 1 for this. Now these all are becoming lonely. Okay, now what is our formula? Number of atoms attached to the central atom. How many atoms got attached? 1, 2, 3, 4 got attached. So 4 I am putting. Then lone pair. It is not asking lone element. Okay, it is pair, means you have to take it in the pair. No, x, right? Single pair. This x, again 1 pair. So how many pairs? Pairs mean 2. 2 single pairs are there. Okay, so 2, which is equal to 6. So if it is 6, what is your hybridization? sp3d2. Clear? Any doubt? No. Now for O, whenever you see O, you need to remember this O will be having two girlfriends, okay? It won't be pairing with a single one like the F, H and everything. This O will go and pair with two girlfriends. It will have two girlfriends. Just for giving you a trick, okay? So, let's say H, I'm sorry. So, how many H are there? Two H are there here. So, I am putting X, X, okay? Now, 1 minute. Yeah, sorry for that. Here, oxygen is your central atom, right? Now, we will calculate. Oxygen is your central atom, no? So, what is your valence electron? It is 6. So, 1, 2, 3, 4, 5, 6, okay? Now, how many hydrogen is coming to pair with it? 1 hydrogen, 2 hydrogen. Are we clear? So, what is the formula? Number of atoms attached to the central atom. How many atoms got attached? 2. Plus how many lone pair? Can you tell me? 1 lone pair, 2 lone pair. Okay. So, this is 2. So, which is equal to your 4 plus 4 is equal 2 plus 2 is equal to 4 and hybridization is sp3. Okay. So, whenever oxygen is acting as your side atom, then comes one trick. Okay. This I told you, no, two girlfriend. That I will show in the next sum. Sorry for telling you here. Here, your oxygen will be the central atom. So, normal way. But here, this is O3. Okay. XeO3. Let's see. If it is X, Xe is your central atom in this case. So, what is your valence electron? How many Xe will put? 1, 2, 3, 4, 5, 6, 7, 8. Now comes the twist, okay? O3 is there, no? As I said, one O will have two girlfriends. It will take two girlfriends. So, or two boyfriends. Whatever. If you think O is a girl, then two boyfriends. O is a boy, two girlfriends, okay? So, it will take, so one O will take two X. So, O. Are we getting here? I paired 1X with 1F. 1X with 1H, okay? But in case of O, 2X with 1O. That is the difference. Another O in and one more O is there, okay? Now, how to calculate the hybridization? It is same. Just to remember that this will take double, okay? Now, number of atoms attached to the central atom. So, to the central atom, how many atoms got attached? 1, 2, 3 only, okay? You should not think it is 2, nothing like that. How many atoms got attached? Only 3, no? So, 3. Now, how many lone pairs are there? Only 1. So, 3 plus 1, which is equal to 4. That will have your sp3 hybridization. Are we clear? This is very simple only, okay? Now, we will see if there are two side atoms got attached, what will be the answer? How to deal with it? Yeah. Here your central atom is Xe. Come on, write with me and try to answer. 1, 2, 3, 4, 5, 6, 7, 8. Right? Yeah. 8 are there. Now, first I will deal with oxygen. Oxygen is only 1, but it will take 2. Putting O. Are we clear? Now I have 4 fluorine. 1, 2, 3, 4. This is being your single. Now, tell me what is the formula? Number of atom attached to the central atom plus lone pair of the atom. How many atoms got attached? 1, 2, 3, 4, 5. 5. How many lone pair? 1. 6. 6 means sp3 d2. Right? Any confusions? Yeah. Let's move on to the next one. This type is when you have a ionic form -2 plus. Okay. What is do? This is also simple. Firstly, S is your central atom, right? Now, let's see what is the valence of your X. 6. So, 6. But if you see, you have -2. So, -2 means 2 electrons are coming to us. These saying add me also in your valence electron if it is minus, okay? So, I am adding +2. Now, your balance become 8, right? If it is plus, you have to minus from the valence. If it is minus, you have to plus from the valence. Any doubt? So, 6 plus 2 equal to 8. Now, we need to put 8x. Okay. You are clear now why I am putting 8 instead of 6. Because we are having -2 here. 3, 4, 5, 6. Oh, 1, 2, 3, 4, 5, 6, 7, 8. O4 is there, no? So, each will take 1. 2, sorry. this 2 is 1O, this 2 is 1O. So what is the formula? Number of atoms attached 4. Lone pair 0, which is equal to 4. So this is for your sp3. Now we will move on to the next question. NH4 plus. Can you try this question? It is also simple. No, I know. I just now told how to calculate if it is a plus or minus. N will be the central atom. You know the valence, and H4 is the side atom. What will you do if it is plus? You have to minus one atom. Sorry, minus one electron from your N, right? So try to do that and tell me the answer in the comments. And if you find any difficulty, let me know. Now we will move on to the next one. Okay, as of now we have seen the the main thing I forgot to tell. See, now it is sp3, but what is the shape? How will you know? That is your trick here. Okay, so what it is? 4 bond pair and 0 lone pair. Now go and check 4 bond 0 lone pair. So it is your tetrahedral. Now you are getting why did we read the short tricks where it is useful. Now let's see for some other. See here. 5 bond pair, 1 lone pair. So what will be the shape? 5, 1, square, pyramidal, BTS trick. Simple, no? So this is how you have to connect the shape. So you know how to calculate the hybridization, how to know the shapes, right? You can give the shape, how to do the bond angle. Now we are going to, this is a simple topic. This we can cover within 3 minutes, okay? So the last topic is to find your bond order, bond strength and length, okay? So just remember this, okay? If sum of your electron, you have to find the sum of your electron and you have to find the bond order for the same. So yeah, simply you need to know the atomic number and we can calculate, okay? If you are getting the sum of electron as 14, 1 minute, yeah, the bond order is 3, that's it. Then if it is 15, minus 0.05 from here, again minus 0.05. 2.5 to 1.51. Okay, start from 14. 14 is the common. Okay, it will be giving you 3. 15 is 2.5, 16 is 2.0, 17 is 1.5, 18 is 1. So if you go above this, like this, 13, then it will be again 2.5. Okay, so this 14 be the common point as 3 and everything be here will be decreasing. Okay, then if it is 12, that is your 2, right? Likewise, you can calculate. Now we will see how to use this trick. Let's say for O2, what is the atomic number of O2? 8, no? Sorry, oxygen is 8. For oxygen, it is 8. So 2 oxygen are there. So if you do 8 plus 8, what will you get? 16. So what is your bond angle now? 2. That's it. Let's see for O2 minus. Again, 2 oxygen are there. So 1 oxygen 8, another oxygen 8. So here minus, just now I said if it is minus, you need to add 1 electron. So plus 1, what will you get? 17, which is your 1.5. Let's say O2 plus 8 plus 8. If it is plus, do minus 1. What will you get? 15, which is your 2.5. Are we clear? You just need to know the number of electrons. Okay, then you can easily get the answer. Now let's calculate for the H2O2. So for O2 you know 16, 8 plus 8, 16. Then how many H are there? 2 H. So atomic number of H will be 1, right? It is 1. So there are 2 H, I am putting 2. Here also we are getting 18, so this is 1. The similar way can you do for KO2? Just calculate for O2, that is 16, and add for K. And give me the answer in the comments. You are clear, right? Simply you should know the atomic number. Atomic number of oxygen is 8. 2 oxygen is there. So I am adding. It is 16 means I know what is the bond length. I memorized with the tricks. It is 2, right? That's it. Now let's see how to calculate the bond length and bond strength using this trick. Okay? Yeah. What it is? Yeah. Now let's say I am having a question. Arrange in increasing order of bond length. Order of your bond length and bond strength for these three. These three we calculated the bond order, right? So let's say how to calculate the bond length and bond strength. See, your bond length is inversely proportional to your bond order. That means bond order increases, bond length decreases. Am I right? So how will you arrange it in the increasing order? Whichever is having the less bond order will be having the highest bond length. That is the meaning, right? So which is having the less bond order here? 0.5. So O2 minus will be your having the bond length. Now what will come next? 2. Right? Then what is the next? O2 plus. Now let's see for bond strength. Bond strength is directly proportional to your bond order. So which is having the greatest bond order here? 2.5. So O2 plus will be the having the greatest bond strength also, followed by your O2, then your O2 minus. Any doubt? So this will be same for your bond order also. So just you need to memorize 14, it is 3, then you can above also, below also you can do minus 0.5 and write this. So with this you can find your bond order, bond strength, bond length. Okay. So we have covered so much of important topics today. If you have any doubt, please let me know. Your tricks, your shape, yeah, bond angle and your calculation of hybridization and this. Okay. If you want any other video from any important core concept, please let me know. Please do watch the short tricks also. See you in the next video. Bye bye.